Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about small power plants. So let's dive right into it. Now, if you are talking about small power plants, we have to understand what is exactly the problem with big power plants. Now, big power plants are very expensive. To give you an idea, most people don't have a context of what kind of money we are talking about. For example, you may see basically a desert and you're like, dude, why don't we put solar farm here? Land is cheap and all that jazz. But once you actually start to factor in the cost, it's like goes into million to billion to even trillions of dollars actually within a reason. And many times power projects take very long time. So interest on those loans actually piles up a lot. So fundamentally, big power plants are ludicrously expensive, and that's why many times you will see, hey dude, this location has like absolutely stable high speed wind, and everybody, like, you put a wind farm here and you're gonna be like YOLO here. Here's the deal, nobody's gonna give you the capital investment. So that cost is a very serious limiting factor for big power plants. Another aspect, when you're talking about big power plant, fundamentally they mean anything bigger than 1000 megawatt. Now again, there is no hard and fast rule about this. It's just like, if you are above 1000 megawatt, you're talking about some serious energy. Now 1000 megawatt requires you to transmit it, and it needs to be transmitted very far out. It's not something that like, okay, there is that small township, I'm gonna give 1000 megawatt. No, you have to give it to a small state or multiple small townships or multiple even 10-15 villages. You have to give that to absorb that kind of energy. So fundamentally, transmission becomes another aspect, and transmission is something that can many times outlive the power plant that created it. So because many times, let's say power plant is like, okay, this power plant has to be shut down, like, it served its purpose, it's like too expensive to repair, and like, let's shut it down. Many time state governments will take that power grid, the line that was created, and they use it as a balancing point. It's like, okay, let's use this link to connect to something else and to balance it out. So that also becomes an inherently expensive adventure. And depending on your location, let's say you live in a Himalayan region or mountain regions, that could become exponentially more expensive than the power plant itself. So that's a thing that you have to also factor into the system. And then it takes a lot of time. For example, many times in past, we used to have what we call ghost towns, because a new opportunity came up. Let's say a short-term opportunity, like let's say there is a lake that people started to use for vacations, and it started to explode, and everybody's going there, and then it started to become useless. It happens many times. Happened with mines, where like, oh, this mine is discovered, everybody is like mining the hell out of it, and everything is awesome, a new town is booming, and poof, it disappears. Because time is critical essence. Before that happens, like, even why do you think Dubai is pouring this kind of bonkers money into their infrastructure project? That's the whole reason. They know that oil is not a infinite kind of resource. They have to have other backup systems, where it's like, before that runs out, we should have something to carry over. So that makes time a very critical asset, so to say. So if you have a town that is dying because of lack of power, you have to have like power right now. You do not be like, okay, you guys hold on for 8 years and I'm gonna build a giant power dam, like, after 8 years. You have to consider time a very serious criteria here. And resource demand is very high. For example, many times people say, oh, China's three gorgeous dam, like, making 20,000 megawatt of power or something like that. It's like, dude, have you seen what amount of concrete it consumed? Like, and the amount of land it devoured, it's like, whoa, like, it's on a satellite map. That whole area is like, poof, gone. Like, if you do that in India, the amount of land that that project consumed, you're talking about displacing almost a small state worth of people, and I'm talking Indian people, so a lot of people. So fundamentally, that's a very serious resource intensive task that you can't just YOLO it. So these are the core problem of big power plants. Even if you have the money, you still have to deal with the three things. So what is our need? Now, when you are talking about small communities, many times they get neglected. Like, your people are talking about, okay, this big city, New York and Delhi, Canada and all that. Canada is a country, basically, Sydney and all that jazz. They are focusing on big towns, but many times small communities get left behind, and they get left behind even by their own government. So fundamentally, you need something that those people can afford. So you need something that does not need too much capital, something that best case scenario, they all can pile up a little bit of money and do it, or they can, like, take out enough loans, like, small loans, that they can easily take care of it. And it should have good control. Fundamentally, when you're talking about power, you want stability with the power. It's just not like, okay, I want 10,000 megawatt. It's not like that. It's like, give me 100 megawatt link, and that is stable. That's like, I will get 100 megawatt no matter what. So you want that stability. That is a very core requirement of system. And if you go solar all in, you get a lot of power, but here's the deal, that power is not stable. Even throughout the day, the power goes up and then goes down. So fundamentally, you are stuck in a position where you have unstable grid. So many times solar panels are connected with what we call grid tie. So grid is like, balancing it out. So if demand goes too low, instead of shutting down power, it sells the electricity back to the grid. So you want something that has good control, especially for if you want to isolate the community and still give them good power. You have to have good control over it. Then we talk about utilizing resources, because that's the end game. Money is just a fancy way of saying resources. So you are talking about, like, let's say water systems. You have to have water in the first place in order to utilize it. Let's say you are talking about biosystems. You have to have biodiversity in the first place to consume. So fundamentally, ideal system is what utilizes the local resources, because those are cheap on that location. So those are our needs here. Now, one system that has started to pick up is micro-hydro systems. Now, these are suited for specifically one country, that is Nepal, and even in some location in India, they are also very well suited. So fundamentally, the idea is, instead of building giant dams, giant system and all that, it's like a small thing. It's like just a small turbine running a small electric motor that is, like, converted as a generator. You can do that with basically normal induction motor. Something simple, and it provides a enough amount of power. It's not GG amount of power. It's not like, you're gonna run a factory with that, but it's enough. And if you are talking about a small group of community people living in a rural area, their power consumption is not that high. They do not have anything to consume power. So it's like, once you build the power plant, then people start to, oh dude, I can buy a television, I can buy a LED light. So fundamentally, they don't even have requirements. So if you are like, dude, I'm gonna sell 100 kilowatt hour, they're like, okay, they can live with that, because they had nothing, comparatively speaking. So fundamentally, whatever power you provide is more than enough. So this system is very low cost effective. Now, United Nations organization, they started a movement where they are like, okay, let's install this in Nepal specifically. I have provided the video down below, and they're like, dude, it's still very expensive. Now, why it's so expensive? Because the equipment is not expensive, and fundamentally it does not require anything expensive, because the labor cost is expensive. Laborers are not free, nowhere it is free. So fundamentally, UN tried a very different approach. They're like, we're gonna give you the tools, and we're gonna give you one engineer or two engineer, however it's needed depending on the project. They're gonna forefront take care of everything. Fundamentally, how the heck you're supposed to do things, but your labor has to come from you. So basically, community has to participate into this. So if they are like, okay, this is the motor, you have to plonk it down here, you're gonna build a basically concrete foundation. We're gonna provide the concrete, but you have to lay down the foundation. So basically, by removing that labor section, they realize they can bring down cost dramatically. Because, like, here's the deal, there are many millionaires, there are many billionaires who give like charities, like, this power plant for this, and it rarely turns out, simply because most of the time people don't account for labor costs. That UN approach was very unique. It's like, does this community want electricity? If the answer is yes, are they willing to sweat for it, not pay money for it, but are they willing to sweat for it? And they did that, and benefit was their own labor created their own power plant. And because most people know exactly how it was built, it was very easy to maintain. So fundamentally, it's a very unique kind of approach, and it does provide low cost system, because fundamentally it's affordable, quote unquote, basically. And you can do something very small, like some people have actually achieved this in a cost of one low capacity car. 24/7 power, that's also awesome. It's not like solar limited, where it's like, nighttime bye bye. And they are generally power rated from 10 kilowatt to 100 kilowatt. So it's good enough for and especially this is one thing that you have to understand. If people have nothing, the first thing they're gonna acquire once they get electricity is mobiles and all that. Just they barely consume any power, and then like lights, street lamps, and not to mention, nowadays all those things are very efficient because of LED. So fundamentally, that may sound very little amount of power, like one video that I'm linked down below, that is around 30 kilowatt of power, but that's more than enough. That town went from nothing to whoa because of that 30 kilowatt of power. However, you have to be very mindful. This is very location specific. You have to have that waterway first place. That is very critical, and it is very seasonal, because river is acting as a buffer. It's like a lot of water mass is there, so it's not gonna evaporate instantaneously, nor it's gonna go up instantaneously. Even rainy season will take time to overflow it. So, and not to mention, that's why when we build giant dams, they have giant reservoir for that exact reason, to buffer it out, and buffer it out throughout a year. So it has to recharge in rainy season and discharge throughout the summer. So that's the whole point of it. Now, when you're talking about something this small, there is not much buffer. So you could literally have a scenario where power disappears in summer, or if you have a dry spell or drought, it would disappear. So that is one thing that you have to be mindful about it. Do not think like, oh, I see a waterway. It's like, what about rainy season? What if it overruns in rainy season, and because you are not connected to anything else, you have to shut down the generator, otherwise you will blow apart the grid. So that's something that you have to take care of. Then we come to biogas. Now in India, biogas was originally, like around 1990s, was pitched as a alternative to LPG, but India's LPG systems worked out way too well, and like nobody uses that. However, biogas as a cooking fuel versus a engine fuel, basically like where you feed it to engine and directly get electricity out of it, it's far more practical. So fundamentally, this is a simple and cost-effective solution. You can build this with a normal building material. You don't need advanced technology. Every Indian village has the technology to do this. Now again, do it more efficiently, more economically, that's a different system, but like just get going. This is surprisingly easy system to do. Now it also allows what we call 24/7 power system, because again, based on your how much your biodigester mass consumption is, basically how much biofeed is going in versus how much gas is coming out. Based on that worst case scenario, you can easily plonk out like, let's say 10 kilowatt to 1 megawatt. There are biogas plants in India that is like around 1 megawatt power rating, some even more than that. So you can easily have that. That's like 1 megawatt. Like India has enough villages in them have more than enough cows to feed 1 megawatt power plant continuously without any shutdown time. So that's doable, and it's very controllable. Now that is a very unique aspect of biogas, because it's a chemical system. You can literally be let's say you take a town, let's say small villages, and you're like, I'm gonna build a biogas power plant. Then you can also add solar farm there. Now the benefit would be you will have a grid tie system where like your biogas plant will work on minimal capacity. Like generally when you're talking about big generators that are talking like megawatts, they have to be running. They do not like to be like spool up or spool down too quickly. So they're like, okay, keep it running and run it at bare minimum, and then you're gonna keep adding solar. So during daytime you're running on basically solar, and that's just running on background, and the night time you directly start using biogas, because you can pile up biogas. Fundamentally that will allow you to double your capacity without having that issue of like, do I add megawatt hour capacity batteries. So fundamentally it's a very good system, awesome controllability, and you can mix it with other things also. So you get a lot of flexibility in terms of power delivery. You can literally match power curves with it. It does have a one serious side effect. How the heck you gonna collect the biomatter? That's the whole issue. Like in India, we have a lot of cows. If we can collect enough of the biomaterial, we will not have energy issues. It's just that collecting that is a very difficult thing. So you have to have like a tight-knit community where you're like, okay, everybody's gonna chip in, and then it can be done. So it's a very good tool. It's a very feasible tool. It's not something like whoa kind of technology. It's something feasible. Like you can go there and just do it. So it's also a very good tool. And if you can solve the collection of the biomatter part, now collection as in like collecting is easy. It's just like how much money or how much effort you are pouring into collecting it. That has to be low for it to be financially viable. So that's the pros and cons of this. Then we come to biomass. Now gas system generally take the biomaterial and they convert it into methane and other stuff. Now methane is burnt into whatever you want to do. Generally people use generators. Sometimes if they have a lot of money, they will use basically turbines, and if they have really lot of money or a lot of good connections, they will use fuel cell. Benefit of fuel cell is they are much more efficient. Compared to 20% you're gonna get out of a generator, you're gonna get around 40% when you're talking about fuel cell, and you will get heat output which is centralized, so you can utilize it properly. So that's one option there. Then you have biomass. Now biomass is very appealing to people where they have a lot of wood industry. So for example, let's say this location has a lot of wood industry. So in wood industry you will have like trees, they will cut down into sizes, and that's it. Now here's the deal, that wasted wood, that is lot, like that's not like in kilograms, that in hundreds of ton. And especially if you have a, let's say, state that is dealing with like this state is focused on wood production and all that, just they will have hundreds of tons of wood waste which they had to take care of one way or the another. And when you're talking about in India, like we have a lot of agriculture waste. For example, we make a lot of what you call vegetable oil. Now vegetable oil has a vegetable stock that is like expelled every time. Now we try to utilize that like using as a fertilizer and all that jazz, but it's not that efficient. So if you have insane amount of that, specifically in those locations where you have native industry, where you have native agriculture waste, you can directly burn it. You can just go YOLO on it, burn it. Now benefit of that, 24/7 power, fully controllable, because that's simply many systems who are running that, they have giant silos where they collect the wood waste. It's like, okay, just keep piling it up. So if they have a scenario where, hey, power requirement is low, they reduce the boiler, fuel consumption goes down, they're like, okay, no problem, we can just keep piling in. So they do not have to deal with a unbalanced system. And another aspect is because of this controllable system, is much more stable. Biogas is a kind of pressurized equipment. You have to have a pressure. It's gonna leak no matter what you're going to do. It's gonna leak slowly. This is far more long-term stable. Basically you can literally have a scenario, for example, let's say a town had like only people pile up here once a month. You can literally have a power plant that only runs once a month. You can't do that with biogas system. Again, it is pileable, but over time it's going to leak too much. This is far more storable, so it does have advantage, and it is far more forgiving in what biomatter you feed into this. You do have to clean the exhaust, but it is doable. And it has the same problem with the other system, is like collection of biomatter. However, whenever these projects are placed, they are fine-tuned with in terms of location. So it's like, dude, it already has the wood waste, let's plonk it right there. It already has this biomatter we can use, plonk it right there. So generally it's pre-taken care of, but you get the point. Now these things that I'm talking about, these three tools, they are very unique kind of. They are not like big bonkers change the world kind of tool, but they are very precise, very useful tool for very small communities, because small communities are generally ignored. It's like, who cares? It's like there were very 1,000 people, but if you can isolate them and you can give them clean, reliable electrical grids, they can progress very effectively, and they will become a much more productive environment. So fundamentally, these sort of tool, they are not suited for, like, I'm not gonna say like put a biomass power plant and try to run Delhi out of it. You're gonna consume 100% of biomatter of India and barely get to do that. So again, there is a right tool for the right job kind of approach here, but these are very good for those kind of scenario. So this was my presentation on small power plants. I hope you liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.